Hello everyone, my name is Shrija. I'm from Department of IT. My mini project is on Ray of Hope, a platform that uses blockchain and web technology for charitable foundation donation. It is being supervised by Dr. K. Ravikaran Sir. The team members who are assisting me in this endeavor are D. Vaishnavi and B. Lavanya. The blockchain-based charity donation system enhances transparency, security, and efficiency in charitable giving, boosting donor confidence and streamlining operations. Despite challenges like regular compliances and scalability, future improvements will be addressed. Continued enhancements will be empower charities and donors to make a positive social impact. Abstract. The project goal enhances transparency, security, and efficiency in charitable donations using blockchain. The cons are issues with traditional donation methods like lack of accountability and high administration cost. The solution overviews are utilizing Ethereum blockchain and smart contracts for real-time tracking and secure fund transfer. Aim and scope. Aim. Develop a blockchain based platform for charitable donations to inspire donor trust and optimize contributions. Scope. Create a user friendly web interface ensuring transparency and security, fostering collaboration and engaging donors through the automatic and real time tracking. Assistance systems. Traditional donation platforms like GoFundMe and Just Giving use centralized servers to manage donations. They offer moderate security and user friendly interface but have limited transparency and potential delays in fund distribution. Blockchain based donation platforms like GiveTrack and Alice use blockchain and smart contracts to manage donations. They offer high transparency and security but can be complex for users, requiring knowledge of blockchain technology and wallets. The existing system includes a simple smart contract backend and frontend for tracking donations. Proposed systems. The proposed system creates a secure, transparent, and user friendly platform for making charitable donations using blockchain. It consists of a client and a server. The server, built with Flask, handles user requests and connects with the Ethereum blockchain. The interactive user interface is constructed using HTML, CSS, and JavaScript. Web3.py and Web3.js allows the application to interact with the blockchain. MetaMask handles user Ethereum wallets. System specifications, software requirements, VS Code, Python 3.x, Flask, MetaMask, Web3.py, Web3.js, LotPlayer.js are software requirements. Hardware requirements, Intel i5 processor or above, minimum 4 GB RAM, Windows, Mac OS, Linux, at least 1 GB free disk space are the hardware requirements and system specifications. Literature survey. Traditional donation platform like GoFundMe, Just Giving. They use regular servers to handle donations. Easy to use with simple user-friendly website. Generally safe to use, not very transparent about how donations are used. There can be delays before the fund reaches the intended recipient. Blockchain based donation platforms like GiveTrack, Alice, they use blockchain technology and smart contracts. Very transparent, everyone can see how donations are used. Highly secured due to blockchain. More compiled to use. User need to understand blockchain and digital wallets. Our application is built using blockchain technology and Flask, which is user friendly, transparent, and less complicated than some of other existing systems. Design use case diagram explains how user interact with the system. The user connects the wallet, then the user can check the balance of their connected wallet, then the user can transfer funds from the user to the receiver. This process includes a step by displaying transaction details. Displaying transaction details shows the specifications of the transaction being executed. The user can view the transaction details of the past transactions. The user can scan QR if he or she doesn't have the digital wallet. This diagram overview of system components and their relationship. The diagram shows that a user manages a wallet creates transactions. The Flask app uses a class named MetaMask, which might be a third party library or a service for connecting a crypto wallet. Overall, this class diagram appears to represent a high level view of mobile wallet applications with a backend server built with Flask that allows user to manage their wallet balance, transfer funds, and live view transaction history. Activity diagram shows the flow of process and interaction within the system. Firstly, the user connects the wallet, then checks the wallet balance, then transfer funds, If the transaction is successful, the user can view the transaction details. If it's not successful, the user can see the error message which is displayed on his screen. Diagram shows the flow of process and interaction within the system. The user connects their wallet to the web server. The web server requests a connection to the user wallet. The wallet sends confirmation of the connection to the web server. The web server then requests the user balance from the blockchain network. The blockchain network returns the user balance from the web server. The web server displays the user balance. The user initiates a fund transfer. The web server sends a transaction initiation message to the blockchain network. The blockchain network presumably validates and confirms the transaction. Overall, the sequential diagram shows how users interact with the web server to view their balance and initiate transfer of fund on blockchain network. The web server acts as an intermediary between the user and the blockchain network. Deployment diagram illustrates the system deployment architecture. The user interacts with the web application on their device. The web application on the user device sends an HTTP request to the web server. The web server processes the request and interacts with the MetaMask extension using a web JavaScript API. The MetaMask extension may communicate with the blockchain node to access the blockchain network. The results are returned back through the web server and displayed on the user device. In essence, this deployment diagram despite a web application that utilizes the MetaMask extension to interact with the blockchain network through a blockchain node. Source code. We can run our application using commands ./run.sh flask run. Our project is a web application built using Flask, a popular Python web framework. The application has several pages: home page, payment page, trusted charity page, contact page. Each of these pages is served by Flask through different routes. Homepage.html. This template is for the homepage of our application. Typically, it contains a welcome message or introductory content about the application. Index.html. This template is for the payment page. It includes functionality for user to connect their cryptocurrency wallet, check their balance, and transfer funds to the different charities. There is a section with buttons to connect the wallet, check balance, and perform transfers. The code includes a pop-up that displays transactions details and allows user to copy the transaction ID. TrustedCharities.html. This template lists trusted charities. Each charity has link to its website, and there is a button for user to donate through the payment page. Contact.html. This template includes a contact form. The form has field for the username, email, and message. There is a button to submit the form. Homepage. There is a fixed navigation bar at top of the page. It contains links to different sections of the website, such as home, trusted charities, how it works, and contact. There are two cards between scrolling section titled Donate and How It Works. These cards provide information about the project, its mission, and functionality. Trusted charities. It contains list items, each representation a trusted charity. Each list item contains a link to the charity website. To open the link in a new tab, donation button is represented by an anchor tag with the text donate. It's linked to the payment page. It initializes Web3 to interact with the Ethereum blockchain. Functions are defined to connect the user wallet, check wallet balance, transfer funds, and the handle pop-up interactions. The page relays on Web3 library for Ethereum blockchain interactions. It also uses lot files for displaying animation in the pop-up window. Contact page. The form consists of input fields for name and email and a text area for the messages. Each input field has a label that transaction to the top when the field is focused or contains input. The button labeled send submit the form, but there currently no JavaScript functionality providing in the code to handle form submission. Result displays the final output of the system, includes home, trusted charities, contact, and index page. The initial screen like to show the main interface of the platform. The user navigates to connect their wallet. The platform integrates with MetaMask. The user is promoted to login. If the user doesn't have the MetaMask account, the user can scan the QR given below to create a MetaMask account. The platform integrates with MetaMask. The user is promoted to login. The user checks their wallet balance. The user enters their amount they wish to donate. The platform processes the transfer, sending funds to the recipient. Transaction details are displayed for the user verification if the transaction is successful. If the transaction is not successful, we can see the error message displayed on the screen. The user can view detailed transaction history, ensuring transparency and accountability. The impact of this project is emphasizing the potential impact on the donor confidence and efficiency in the charitable giving. Conclusion. The blockchain based charity donation system significantly improves charitable giving by using blockchain technology to enhance transparency, security, and efficiency. It features user friendly interface, robust backend system, and smart contracts that automate donations, boosting donor confidence and helping organizations streamline operations. The system implementation shows it can handle seamless transaction and secure, transparent fund flows, increasing user participation despite challenges like regular compliance, scalability, and user education. Thank you.